So yeah, welcome to my presentation, Meerkat in the Sandbox. I would like to talk about how we use SuriCata in our Proofpoint sandbox and how we score and weight the rule alerts to influence the overall verdict of a sandbox run. There have been some talks already and presentations around rule scoring and metadata enrichment, especially like last year's Aristotle update from Dave Wharton inspired me to give this presentation. And yeah, let's dive into it. So who am I? I'm part of Proofpoint's threat research team. I live in Bern in Switzerland. I used to work in detection engineering, focusing on all kind of detections except Suricata, because that's what the emergent threats team is doing in our threat research team. And I also work on the sandbox development. I'm now transitioning into a more CTI-focused role into the espionage team of our house. So during my past roles, I used to be an ET customer, a Suricata sensor developer, and a network analyst. And now I'm also still a customer of the emergent threats team, but with a more short way to talk to them, which is a lot easier in some ways. Yeah, so first we are gonna talk about the agenda on a Friday morning on day 3 of the conference. We need, to tell what we else need except coffee. Oh, damn it, whatever. So why do I do this talk? We are going through our detection pipeline and introduce our Kukua-like sandbox. Then we are going to check out how Suricata is integrated in that sandbox, and then how we are getting the choose from the rule metadata and calculate score and metadata for the alerts. And lastly, we are going through examples and see how all works together. So motivation, I already mentioned, last year's presentation has been inspiring me. There was also in SuriCon 2019, Aristotle version 1, I think, from Dave Wharton. I've been attending quite some SuriCon so far, and this topic of alert triage, or which can easily lead to alert fatigue, has always been a topic. It's also a popular topic to use rule metadata and enrichments to score rules and come to a verdict of a rule. So we've seen that in last year's presentation, but also back in 2019. And we've also seen that in 22 and 25 by colleagues or ex-colleagues from the emergent threats team, presenting on that topic. So I want to show you how we use the metadata of the ET rule set to enrich and score our alerts to influence the overall verdict in our sandbox runs. There is no plug and play, no matter how you deploy your sensor. Suricata and rules produce alerts, but you're not just secure by plugging it in. It always depends on the traffic that is connected to your sensor. So if you have real traffic, it depends on the environment where the sensor is deployed. And you need proper baselining before you can use the rules in a useful way. Also, if you have sandbox or lab traffic, you also need that kind of baselining. We've already seen some talks how to baseline a sensor in the past years, for example, to use PEFMAS tools, or baseline a rule set with Aristotle. This presentation is to share our approach within our sandbox environment. Maybe it inspires you, maybe it inspires other sandbox vendors to do a similar thing. So let's see what we did before we switched over to that new approach, which was also motivating for me to do it. So we did things like that. We were checking for keywords in the rule message to basically give the rule a higher or lower weight, which is terrible. Or things like that. We were checking if there is a fish or successful fish in the rule message to, say the fish was successful and maybe give it a higher score in the sandbox. or a huge list of safe listed signatures. So why do we need to change? I think I don't need to explain, but it's like horrible and unmaintainable code. The verdict or the score of a specific signature or new signatures is very hard to predict. There is literally no control on the emergent threat sides what's going to happen with the signature on our side. And every code update in this Python code needs, of course, a deployment or a signature push from our end. And yeah, that can have some kind of delay. So at this point, you might ask the question, what are we even doing with our sandbox? That's a good question. Last year, I gave a talk with Matt Bing over how we fight network-based threats and evasions in our sandbox environment at SuriCon. And I introduced our pipeline that scans emails, extracts URLs and files, and then sends them to a static and dynamic engine. The dynamic engine or sandbox is what we focus about today. It's also where Suricata is included. So we can scan those URLs and files either with a headless browser or a virtual machine. And the concept we follow is called DDX, which stands for detection, detonation, and config extraction. And we try to get the attack chain detonate from the start, which is the email, and then we try to get as much as we can get what comes after. So if we download and detect interesting files or URLs during the detonation flow, we throw them back in and resubmit them at the start. In this specific case, we had an email that contained an encrypted zip with the password in the message that we need to open. And then we get a jar file, which we call alien loader, that tries to download Picabot malware from a URL. And last but not least, of course, it's always good to extract the configuration of the final malware. So that's the background of the pipeline. We're zooming into the dynamic part of it, which is a Cuckoo-like sandbox. I guess many of you already heard about the OG Cuckoo. We run typical Cuckoo Python signatures, Yara rules on files and memory, and Klinger and SuriCata in that sandbox. There are also other open source there are also other open source and also commercial sandboxes that use what I call Cuckoo-like sandboxes like OG Cuckoo or Cape v2, and countless modified forks and versions of it. On the commercial side, I think Hatching Triage and TwinWaves Attack Analyzer are the two most famous ones to mention here. So what makes the sandbox a typical Cuckoo-like sandbox? It's the concept of those Python signatures. On the slide, you can see a typical header of a Cuckoo Python signature. This specific one is also open source, and I have it on the last slide. I included all the links to the public work I mentioned in this talk. So it's for the mentioned Java loader that downloads Picabot that we call alien loader. And you can define certain things in the header, like, for example, the malware family or the weight or the severity of a signature. And those values define the final verdict of the signature in the sandbox run. You can also see that you can define, for example, MITRE techniques or other metadata. And this specific signature is running in the VM, not in the headless browser. And as it's for a file, a Windows Java malware file. And it obviously listens to our API hooks, in this case, to 5 different Windows APIs, which we can see here. So usually when you build such a malware behavior signature, you build a state machine and you concatenate the different Windows API calls and the behavior they did together to make a signature that is specific enough, that is generic, as much generic as you can get it, but specific enough to only match on the malware or the behavior that you want to match it on. Yes, so you have the send, you have the anti-create file, you have the wait for multiple objects, and the create process internal, and you concatenate that together into a state machine. And finally, you can say, okay, this behavior, that's alien loader. So how does that work in the sandbox? Kukua-like sandboxes typically run a sample first and collect the logs. Then they have a pre and a post processing step. And finally, they create a report for the UI and a JSON report. So what happens in those steps? During runtime, of course, we scan and run the URL or the file inside the headless browser or virtual machine. And on the network side, we capture the raw network traffic. We store the TLS secrets. We use TCP dump and certain hooks to inspect the network traffic and generate the PCAPs, which we then do in the pre-processing step to create like the static and dynamic behavior report. And then the network side, the PCAPs are actually getting generated and scanned with SuriCata to get the ETH JSON. In the post-processing step, then we do the actual scoring and running of the Python signatures to determine verdict. In this step, we are also like interpreting the ETH JSON and do the actual scoring of the SuriCata alerts and the metadata enrichments. And the reporting, we get the final report, what you can see after the sandbox run is done. So that's how it would look like in Cape. In this case, it's a malware called Aura Stealer, and you can see it also extracted the configuration. Cape has this kind of either condemning or non-condemning info signatures. So in this case, it's a condemning run versus our Kukua-like sandbox. We introduce a score from 0 to 10, and the various Python signatures return a score that then gets summed up to the final score. And if the score is higher than 6, we call it malicious. And I think I have to mention it has a massive impact if we determine something as malicious, because we then actively block the emails. So FPs are very bad, so we have to be like very sensitive with that kind of scoring mechanism. In this case, we see a run of a TA402 OWA phishing URL, which triggers multiple signatures in our sandbox. And the one I highlighted here is like the SuriCata signature, which scores and successfully identifies this as TA402. And finally, it leads to us condemning the signature. So how do we use SuriCata in that sandbox? First, we need PCAPs. As mentioned, we store the TLS secrets and use TCP dump and man-in-the-middle proxy solution to generate a normal and decrypted PCAP. Last year in our presentation, we open sourced a tool called Fake PCAP, which I also have in the links, which is one of the tools we use to create the decrypted PCAP. Obviously, as it's a sandbox, we also have hooks into the actual network API calls. So we follow a defense in depth approach to match, to detect the bad network traffic, not only with SuriCata, but also we have the possibility to match on the API calls from the hook. One example, for example, is HTTP2. Before Suri supported HTTP2, we could only inspect it with our hooks, and eventually we transformed HTTP2 to HTTP1 to give it into the PCAP before we run SuriCata, so that we could still inspect it. So HTTP in SuriCata was like a huge uplift of our network-based detection, because we can now inspect that with SuriCata naturally. Another thing is we are very much looking forward to the WebSocket in Suri 8, because right now the only way we inspect them is via hooks, and then we can have a second option to also check them out. On the rules side, we used pulled pork and moved to SuriCata update to update the rules. We use, of course, the ETPRO rule set. and some internal IOCs and sandbox related rules, a few third-party rules, and of course like Lua rules from Dr. Lua and others. We update the upstream rules once a day because ET also publishes a new rule set once a day. But if we need to do internal rule changes, a rule reload would get triggered immediately. On the Suricata side, we are on Suri 7 still. We use the Unix socket mode and Suricata SC, and we have 5 sockets, and the PCAP gets sent round robin to each socket, and we always have a second chance. So if there is an error or a timeout, we still try another socket for a second time. The timeout for one of those socket runs is 120 seconds, and the overall timeout for the whole Suricata model is 10 minutes. We cap it. Yes, if we trigger a rule reload, we reload one socket after each other so that we also don't lose any PCAP in the rule reload time. We have all protocol passes enabled and the logs only for them that we are actually using right now. We have also file store enabled, and like for the HTTP buffer settings, we have set it like to the maximum settings. So it's like not very performance sensitive what we do with our configuration right now. Yes. So that's how it looks like. From a user perspective, you have many tabs for different topics. One of them is the network section, where you can get the PCAPs and get like detailed info on the Python processing and the Suricata processing of the network traffic. And for example, that's a file extracted from Suricata via file store. And this is, I want to show that we also like display the metadata from the if JSON to like give more information on the alert. So let's pull some numbers. I did that last week. We had around 1 billion sandbox scans in our production environment in the past 30 days. And the question is, how long does it take to process the whole Suricata processing model? And well, yeah, it's between 0 and 600 seconds, which is the 10-minute time cap I mentioned before. And 0, of course, because sometimes samples don't do any network traffic, so we don't run Suricata at all. The average it takes is 1.4 seconds, and the average, I have to mention this, I only included the runs that have a non-empty PCAP. So the 0 ones are removed from there. So now the question about the timeout, obviously, how often does it happen that we reach that 10-minute timeout? That's how often it happens. So I think the max value is like 20,000 a day. So there's some room for improvement on the perf side of things, but given the scale we're running, it's still very few. And the next slide is give you a bit more insight into this. Our timeout obviously also defines the maximum size of the PCAP in the sandbox run, or like the time how long we run the sample in the sandbox, of course, defines that. So if there are big file downloads, things get rescanned in a different cluster, which is not included in this metrics. So that's why you probably see the 105 megabyte as the maximum size of the normal and decrypted PCAP size in both ways, because that's basically all that we can get in the time we have. Again, like the average size of PCAP is 1.4 megabyte for the normal one and 4.4 for the decrypted one. So it's still, very small, and you can run it very quickly through Suricata usually. So how do we calculate the score and extract the metadata and get the juice out of it. We talked a lot about the sandbox, so let's see how we are actually doing that. I have to give shoutouts to Brandon Murphy for the initial idea when he was with us. So the idea was to make ET team responsible for their rules and don't try to score them yourself anymore. And the simple algorithm goes confidence multiplied by severity multiplied by category. And that was like a huge philosophy or mindset change for us. We have those SuriCata alert and SuriCata TLS alert signatures, which are nothing else than Python signatures, like the one I showed you before. And those signatures loop over the alerts from the if JSON, and they pull all the metadata from the if JSON. And then we give control to ET using the signature metadata over the weight, the severity, the category, the family, and the micro techniques of the Python signature, and something that we call click block, which I have to explain. Sometimes you have infected websites with like injects like SockGolish or ClickFix, and those are legitimate websites, and you don't necessarily want to block the legitimate emails from them, but only want to block the click on the URL. So that's a flag that we can set here basically. Okay, we pull out those metadata from ET. So confidence in ET signatures can be low, medium, or high, and it gets a multiplier of 0, 0.5, or 1. Severity can be informational, minor, major, or critical. It also gets a multiplier. And then the category like ET phishing or ET malware, it gets a multiplier or defaults to 1. And maybe there are some rules that you don't want to score at all, like ET info. You safe list that category and it will get a 0 as multiplier, so it will end up with 0 in the end. And yeah, that's basically it. There is not much rocket science in this approach. We started this in 24 in shadow mode and baselined it before pulling the switch. But we use it in production for more than a year now, and we didn't have any major problems. ET also put a massive amount of work into doing like cosmetics of their metadata and updating them. And there was also like a blog published about this earlier this year, how to do that at this amount of rules scale they have. So yeah, thank you very much for doing that. So then answer some questions before we dive into the examples. So yeah, how do we handle FPs? Yeah, that was the whole point. We wanted to make ET responsible for the rules and try to score themselves. So if we have false positives, we report them to the ET team, and then it will lead to a change in the metadata, or we can also, of course, safe list or disable a rule in our environment only if we don't think the rule makes sense at all in our environment. Next question, why don't we use Aristotle? So it was a little bit of an overkill for our environment. This one is just much simpler and easier. And we can use like our small distance to the ET team to basically, yeah, improve the rule set for everyone, not only for us. What's next? That's of course WebSocket. I already mentioned it. Right now we use IOC-based rules for domains and things, and of course we should move to datasets. Yeah, we should have done that already some time ago, but yeah, that's on the roadmap for next year. Of course, always improvement in UI and log representation, and HTTP3 is also something we are very much interested in. So yeah, let's see how that all works together and look into some threads. So I already mentioned that there has been a rise in the last years on like TDS redirects that lead to clickfix, sockgolish, copyfix kind of threads. In this case, you can see a legitimate URL that is somehow infected and then redirecting to this clickfix thread, where you should copy the command and run it on your shell. And in this case, there are multiple network Suricata signatures firing, and I want to highlight this one explicitly, the ET exploit kit one. So you have the category exploit kit, you have the confidence high and the signature severity minor, and then you have the tags TDS compromised website and also the actor name. And then you can just use the algorithm and score it, which in this case leads to 0.378, and combined with the other signatures, it then sums up. Next example is on the same run, the ET shellcode one. So shellcode was not defined as a safe list category, but also not defined in an explicit weight. So it just defaults to 1 in the category multiplier. You again have high confidence, major severity, and then in this case we also set a miter technique, which we also extract out of the signature metadata. Then we have a Lumma Stealer signature, where I want to highlight the fact that it's not only the score that we extract from the metadata, but also the miter techniques and the malware family. So in this case, the malware family is set to Lumma, which you can also see then in the final run. And again, we score the signature, and we extract the miter techniques. Let me go one back. Yeah, this is also the slide. It's way too small, but this is the slide where we have basically the miter metrics of the sandbox run, which you can see on the picture below. And you can basically see which signatures have set certain miter techniques. Not only Suri signatures can do that, obviously, but also other signatures. But Suricata is one of the engines that set those techniques. I already did a shout out, but in this case, we observed an HTTP 2 download from an MSI file via HTTP 2. Kind of nice to see that in Suricata and not only with other measurements. So yeah, that was a huge improvement for us in the last years. Yeah, that's basically it. I want to give shout outs to Chinina and Stu from the ET team. They are here, they write rules every day. We have Chris Wakelin on the Lua side and also the ET product manager. So feel free if you want to reach out to them for the emergence threat side of things, and feel free to reach out to me with questions on the presentation. Thank you.
Questions? Hey, Dave's first.
Appreciate the presentation. Quick question, and maybe I missed it, but what if you have multiple rules triggering on a PCAP run? How do you do that scoring?
We just sum up the individual scores of the rules.
So if one rule scored a 0.6, one point scored a 0.5, you'd have a 1.1.
Yes.
Okay.
Thanks, Konstantin. Can you reshare that slide or code in a link that shows all the scoring details, like how you categorize or what score you give a category and stuff?
Yes, I tried to make a slide with like the summary and the details. Yeah, it didn't went well on the slide, but I can share it.
Okay, and I'm wondering if it would make sense to kind of have something like Suricata update, calculate the score, and become a filter, because maybe I want to filter out all low score stuff from
yes,
my rule set.
Makes sense. I already have a helper function that does that.
Okay.
So I can share that with
All
you.
right. Thank you.
Would it make sense to have the score actually be part of the metadata of the rule so that we don't have to calculate it, but that you just have a scoring number and communicate to the users like this is, this is our judgment on this is our verdict?
It's a good point. I think it always depends on where you run the rules. So in some environments, you want one category having a higher score than the other. So I think you still always have that individuality in where your sensor runs, what you want to do with the rules. So maybe sometimes you want to give like exploit kit a much higher category than in the sandbox. So yeah, I don't think we can make it at all in the metadata.
Right. So maybe it makes more sense to have this as local configuration and then as input to the formula.
Yes.
Yeah. Okay.
Basically, yeah, that's basically the local configuration. It's way too small, but that's where I define for our environment what category gets which multiplier, and that could certainly be like a config file in the Suricata update, and then we could also write a score in the rule itself.
Right.
In Suricata update, yeah.
I guess I see the scores are the weights are very precise, like 2 decimal points. Like, how could we expect actual users to make that judgment? That would, I guess, be the follow-up problem then.
Yes. So we run it in shadow mode for quite some time, and then we played with the numbers to don't have false positives, but score high enough that you also don't have false negatives if you don't want them. That was our way to do it. Of course, because it's a sandbox environment, the traffic we see is always pretty similar. Like there are no surprises that this is going to change pretty time soon. Where I mean, on a live captured sensor, the traffic can change very much quickly. Yeah, it always needs baselining. But that's a very good idea to have it in Suricata update.
Other questions? No? All right. Thank you very much.